Okay, so let's look at another example. Solve using the quadratic formula. So we were saying before that in order to use the quadratic formula, our equation has to be in the form ax squared plus bx plus c equals 0. So before we can decide what the values of a, b, and c are, we're going to have to get our equation into this form. And basically it just has to be that one side of our equation is 0. So if I want, one side of our equation, it has to be simplified, and one side equals 0. So I could go ahead and add 4 to both sides of our equation. And so I would have 0 equals, and I'm going to rewrite the right-hand side in descending order. So that would be negative 5x squared plus 19x plus 4. So I'm at the point now where I could go ahead and assign values for a, b, and c. I could say a is negative 5, b is 19, and c is positive 4. But I always prefer for my value of a to be positive. I just find for myself and for my students that there are less sign errors when they go ahead and let a be positive. So before I assign, I am going to go ahead and multiply both sides by negative 1. I know that if I multiply both sides of an equation by the same value, I am writing an equivalent equation, but I'm just doing, in my opinion, a favor to myself by making that value of a positive. So I have 0 equals 5x squared, right? I'm basically taking this and distributing my negative 1. So it'll be positive 5x squared minus 19x minus 4. So the value of a is positive 5, the value for b is negative 19, and the value for c is negative 4. So taking our values for a, b, and c and plugging them into the quadratic formula, again, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You must memorize that formula. Of course, you could derive it every time like we did in the first video, but it's going to be easiest if you go ahead and memorize, okay? So opposite of b, when I look at the b is negative 19, so the opposite of that is positive 19. So we have positive 19 plus or minus the square root of b squared, that's negative 19 quantity squared, minus 4 times the value of a times the value of c. I'm going to just extend all this, all over 2 times 5. Okay, so what I have so far, I have 19 plus or minus the square root of something. We'll work on that discriminant in a minute. And 2 times 5, we've got 10 in the bottom. Okay, so when you're working on doing this simplification, when you're finding the value of this discriminant, negative 19 squared minus 4 times 5 times negative 20, let's look at that. We'll kind of pull this up here. So if I multiply negative 19 times negative 19, I get positive 361 minus, so I think of it as minus 4 times blah blah blah. So I ignore that for now, and I just multiply 4 times 5, which is 20, and 20 times negative 4, I get negative 80. Okay, so I have minus a negative 80, and minus a negative is plus. So this is 361 plus 80. Your other alternative is to, when you're doing your multiplication, you can think of this 4 as negative. So a negative times a negative, you're going to end up with a plus. But you have to make sure that you realize that you are either going to be adding or subtracting those two numbers depending on the sign. So going further, the 361 plus the 80 we end up getting 441. Okay? So, doing our simplification, you have to play around with that 441 a bit, especially if I have a large number. I'm going to go ahead and see if that is a perfect square. So if I, on my calculator, do the square root of 441, I end up with 21. So that was a perfect square. I didn't need to break it down like I have in the past. I can just find the square root of 441. So we have 19 plus or minus 21 all over 10. So again, the plus or minus means one solution is 19 plus 21 over 10, and the other is 19 minus 21 over 10. And we have no i's, no roots. You know, we can do this math. If we add 19 and 21, that would be 40, and 40 divided by 10 is 4. So 4 is a solution. The other, 19 minus 21, that's negative 2. And if we have negative 2/10, we need to reduce that to a negative 1/5. So the solutions to this quadratic equation are both 4 and negative 1/5. Okay? And the fact that I ended up with these rational solutions, no i's, no roots, that tells me that I actually could have solved this equation by factoring. Okay? It would have worked if you had tried to factor. Let's look at another example. So again, we want to solve using the quadratic formula. So the big thing that you need to be thinking when you're trying to use the quadratic formula is, before you assign values for a, b, and c, you need to make sure that you have the equation in the form so that it's simplified and equal to 0. Okay? That's key for using the quadratic formula. Your equation has to be simplified, meaning we've got, parentheses taken care of, and like terms are combined, and then also one side is equal to 0. So in this case, if we distribute that x, we'll have x squared minus 4x plus 3x plus 20. I'm sorry, not plus, equals 20. Negative 4x plus 3x, we've got negative 1x, so that's x squared minus x. And I know I want one side equal to 0, so I'm going to go ahead and subtract that 20 on both sides. So I end up with the simplified equation x squared minus x minus 20. And most of you are looking at this saying, well, I can definitely factor that. And if I had not said solve using the quadratic formula, I definitely would want you to solve that by factoring. But because we're practicing our use of the formula, we are going to continue in that direction. So now that I have ax squared plus bx plus c equals 0, I can see I'm going to use 1 for a, I'm going to use negative 1 for b, and I'm going to use negative 20 for c. So the value for x is, opposite of b is positive 1, plus or minus the square root. Negative 1 times negative 1, b squared, is positive 1, or let's go ahead and write it, negative 1 squared minus 4 times 1 times negative 20, all over 2 times the value of a. So we have 1 plus or minus the square root of, so negative 1 times negative 1 is 1, 4 times 1 is 4, 4 times negative 20 is negative 80, so we have 1 minus a negative 80, or 1 plus 80, which is 81, all over 2. 81 is a perfect square, and I was expecting that. The fact that I knew I could factor this, I'm expecting this to be a perfect square, because I should end up with rational solutions, no i's, no roots. So I have 1 plus or minus 9 all over 2. So the 1 plus 9 is 10. 10 divided by 2 is 5. So 5 is a solution. 1 minus 9, we have negative 8, and negative 8 divided by 2, that is negative 4. So the solutions to this equation are positive 5 and negative 4. If you go back to this point here and think about the factorization would be x minus 5 times x plus 4 is equal to 0, right? X times x is x squared. Negative 5 times positive 4 is your negative 20, and negative 5x plus 4x is your negative 1x. And from the factorization, for the product to equal 0, your x would have to either equal 5 or negative 4, which we get the same thing when we solve by factoring as when we do by using the quadratic formula. Regardless of the method, the solutions should be the same. Okay? Solve this guy, x squared minus 24 equals 0 using the quadratic formula. So hopefully you are looking at this quadratic equation and saying, well, it would be a lot easier since we just have x squared and a number. The easiest way would be to add the 24 to both sides, and then we would have x squared equals 24, and we could just take the square root of both sides. And I agree, that's the easiest, and that's what I would encourage you to use if I wasn't trying to make a point or show you how you would be able to solve this using the quadratic formula. But you can, okay? Again, quadratic formula can be used for any equation, any quadratic in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is non-zero. B can be 0, C can be 0, and that's what we have in this case, is we basically, we have an x squared, so the value for A will be 1. We have a constant, so C will be negative 24. Since there is no x term, the value for B is 0. So if we're using this, solving this using the quadratic formula, we'll have to use A is 1, B is 0, and C is negative 24. So x is opposite of B, opposite of 0 is just 0, plus or minus the square root of 0 squared minus 4 times A times C. I always leave that short, all over 2 times A. So we have 0 plus or minus the square root of, so 0 squared is 0, 4 times 1, 4, 4 times negative 24 is negative 96. So we've got 0 minus a negative 96, or 0 plus 96, this is just 96, all divided by 2. So 0 plus something, that's just that number, so what we really have is plus or minus the square root of 96 over 2. So doing our simplification, this simplifies if 96 is divisible by a perfect square. So if I go through my list of perfect squares, I find that 16 is actually the largest perfect square that goes into 96. So this would simplify to plus or minus 4 root 6 over 2. But I can simplify that fraction. The 4 over 2 is just 2. So 2 plus or minus 2 root 6, or positive 2 root 6 is a solution and negative 2 root 6 is a solution. And please note that this is the same solution set you would have gotten had you solved by extracting the root, which would be the most efficient and or fastest method to use. So I've kind of been talking a little bit about the discriminant, but it's a nice, in theory and in application, to kind of look at what the value of the discriminant is going to be and kind of get a feel for the number and the type of solutions that you should be expecting. So again, when you're dealing with the quadratic formula, The discriminant is that part, that b squared minus 4ac. Okay? And if the discriminant is positive, then you're going to get real solutions, right? If you end up getting a negative, the square root of a negative number would have i's. So if it's positive, your solutions are going to be real. They're either going to be rational or they're going to be irrational, right? If what you end up here is a perfect square, then you won't end up with square roots, and so you'll have some rational solutions. If it's a positive number that's not a perfect square, then you're going to have some roots still left in your answers, and so you'll have two irrational solutions. Okay? If that discriminant is negative, if whatever you have here is a negative number, then you're going to be taking the square root of a negative, which is going to result in getting i's. So if the discriminant's negative, you will have two non-real complex solutions. Complex solutions, complex numbers that are not real. We specified that, remember, because the real numbers are housed in the complex. All real numbers are complex as well. And then finally, if your discriminant is 0, then you're going to have opposite of b plus or minus the square root of 0 over 2 times your a. So the square root of 0 is just 0, and so it really just simplifies to negative b over 2a. Okay, so if that discriminant is 0, you're only going to have one solution. You're going to have one real numbered solution, which will be the opposite of the value of b all over 2a. So some things to consider, and you'll see more uses for this later, especially when we're working with graphing of quadratic functions. So let me know if you have any questions, and good luck.